Hello everyone, in this video we are going to learn about the categorical plots and following are the topics that we are going to discuss. Firstly, we will learn about the violin plots. After that, we will discuss about the strip plots. Then we will also learn about the swarm plot and the factor plots. So let's begin the topic by understanding what are the violin plots. So basically, a technique for visualizing the distribution of a numerical data for various variables is called a violin plot. It is similar to the box plot, but it has only the difference. It is rotated plot on each side, providing more details about the density estimate on the y-axis. And it also has a shape like a violin, which is produced by mirroring and flipping the density. And the benefit of the violin plot over the box plot is that it can highlight variation in the distribution that box plot can't. So in Seaborn library, if you want to create a violin plot, we use the function violin plot. And the syntax of this function is Seaborn dot violin plot, and in parentheses we pass different argument. The first two arguments are the x and y. It is the data points that define the x and y axis location. The next one is hue. Basically, it groups the variable that will produce component with different colors. And the last one is data. It is nothing. It is only the data set that we are going to use. So we will learn about this topic in detail with the help of an example. I will show you the example first. So here is the example related to the violin plot. I will explain you line by line. So here you can see that firstly I call the violin plot function, as I want to visualize the data between the mjob and the failure data point of the student underscore data set. Then I want to add labels at the x-axis and the y-axis. So I call the x-label function and the y-label function of the pyplot module of the matplotlib library, and I pass label as an argument to both of the function. Addition to this, I also want to change the font weight and the color of the label. So I pass font weight and the color as a keyword argument to both of the function and set its value bold and Y. Here Y stands for the yellow respectively. Then I want to add a title on the plot, so we get to know what this plot represents. So I call the title function, pass title as an argument. Then addition to this, I also pass font size keyword argument and font weight keyword argument to change the font size and the font weight of the title, and I set its value to 10 and bold respectively. And in last, I call the show function as I want to show the plot on the user screen. So now I execute this code and show you the output. So here you can see that it creates a violin plot. It shapes like a violin. You can see that. Here the y-axis represent the student failure rate and the x-axis represent the mother occupation. So we conclude that from the title, this plot represents the mother occupation versus student absence rate. So now we will move ahead and see one more example of a violin plot. So here I call a violin plot function as I want to visualize the data between age and the G2 grade of the students. And additionally, you can see that I pass a hue keyword argument to the violin plot function as I want to group the address data points with the different colors. So next I call the x label and the y label function for adding labels at the x-axis and the y-axis. Then I call the title function to add a title on the plot, and then I call the show function to display the plot. Now I execute this cell also and show you the output. Here you can see that it creates a violin plot with violin like a structure. Here above it shows the legend which show the hue. Here the blue color violin represent the urban area and the red color violins represent the rural area. And here the y-axis represent the student grade 2 and the x-axis represent the age of the student, and the plot represent age versus grade 2 of the student. And you can see that here the labels at the x-axis and the y-axis are shown in the yellow color as we have defined the color as a yellow in the x label and the y label function. So with this, we have learned to create a violin plot in the Seaborn library. Now we will move ahead and learn to create a strip plot function. So firstly, we will understand what is strip plot. So basically, the strip plot is utilized to create a scatter plot based on the category. And it is a good complement for the box plot or the violin plot in the case where all the observations are shown along with some representation of the underlying distribution. And you all know that by default the catplot function draw the strip plot. So in Seaborn library, if you want to create the strip plot function, you have to call the strip plot. And in Seaborn library, if you want to create a strip plot, you have to call the strip plot function. And the syntax of this function is Seaborn.stripplot, and in parentheses we pass different arguments. So the first two parameters are x and y, that are the data points that defines x and y axis location. The next one is hue. You all know that it is a grouping variable that will produce a components with different color. The next one is marker. By default it has a circle value, and if you want to change the style of the marker, this keyword is used. The next one is edge color. It is the color of the lines around each point, and by default it has a gray color. The next one is line width. The width of the gray line that encloses the point element is defined by the line width, and by default it has a 0 value. The next one is size. It is the marker radius size in the points. The next one is dash, and if you set its value to true, it will separate the strips from the various hue levels along the categorical axis. And the last one is data. It is the data set that we are going to use. So I will explain you this function with the help of example in detail. So here is the example related to the strip plot. You can see that for creating the strip plot, I call the strip plot function as I want to visualize the age and the free time data point of the student underscore data set. Additionally, I want to change the style of the marker, edge color, and the line width of the marker also, and size of the marker also. So I pass, here you can see that marker as a keyword argument. Here I set its value to D, which means diamond. The next I pass a keyword argument edge color, and I set its value to K, which means black. Then I pass a line width as a keyword argument, and I set its value to 0.3, and you know that by default it has a 0 value. Then I pass a keyword argument size, and I set its value to 10. Then I want to add labels at the x-axis and the y-axis of the strip plot. So I call the x label function and the y label function. I pass labels as an argument to both of the function. Addition to this, I want to change the font weight and the color of the labels at the x-axis also. So I call the font weight keyword argument and pass it to the both of the functions, and I also pass color to both of the function, and I set font weight value to bold and color value to orange. Then I call the title function as I want to add a title on the plot. So I get to know what this plot represents, and I set its font size to 10 and the font weight to bold by passing font size and the font weight as a keyword argument to the title function. Then I call the show function as I want to display the plot on the user screen. So now I execute this cell and show you the output how the plots look. And here you can see that this plot has a marker shape as a diamond, and here its y-axis represent the free time and x-axis represent the age. And here you can also see that the x-axis label and the y-axis label are in orange color, and from the title we get to know the age versus free time is represented by this plot. So here you can see that from 16-year age student have near about 1.0 free time, near about 3 students, as it has 3 diamonds. So it represents the 3 students. So now we will see one more example, and this time I again call the strip plot function as I want to visualize the sex and the G3 grade of the student. And addition to this, I pass the hue as a keyword argument to group the study time data point with different color. And I also pass the darts as a keyword argument and I set its value to true because I want to separate the strips of a various hue level along the categorical axis. Then I call the X label and the Y label function to add labels at the axis. Then I call the title function to add a title on the plot and the show function to display the plot. Now I execute this cell also and show you how these strip plots look. Here is the output. You can see that here x-axis represent the gender of the student, male and the female. Y-axis represent the student grade 3. And here you can see that from the marker it separates the strips for various hue level along the categorical axis. So here the blue color represent the 1 as a study time, orange as a 2, green as a 3 and the red as a 4. You can see that they are separated. Like the blue one is shown first, then the orange one, then the green one and then the red one. And these strips are shown separated only because of this dash keyword argument. Now I will show what will happen if I false this argument. So I false this one and now I execute this code and I will show you the output what will happen. You can see that now and here you can see that it will show the green color, blue color, orange color, red color as a combined strip, not the separated one. So from this, I hope you will understand that the dash keyword is used to separate the strips. So I again set its value to true and execute it. It will again separate the strips. So with this, we have learned to create the strip plot. So now we will move ahead and learn to create the swarmplot in the Seaborn library. So in the Seaborn library, swarmplot is likely similar to the strip plot with the exception that the points are adjusted to avoid the overlap in order to better depict the distribution of a value. And in Seaborn library, you have to call the swarmplot function to create the swarmplot. And the syntax of this function is seaborn.swarm and in parentheses you have to pass the different parameter. The first two are the x and y, the third one is hue and the last one is data. You know that what these parameters mean. So I will explain you this function with the help of an example and we will learn to create the swarm plot. So here I write a code, so I will explain you it. So firstly I call the swarm plot as I want to visualize the data between the sex and the health of the student, and addition to this I pass the hue keyword argument to group the p status data point with different color. P status means parent status. Then I call the x label and the y label function as I want to add labels at the x axis and the y axis. I also change its font weight to bold and color to gray. Then I call the title function as I want to add a title on the plot. I set its font size value to 10 and the font weight value to bold. And last I call the show function to display the plot. Now I execute this code and show you the output, how these plots look. So here you can see that it shows me the warning. This warning is because it has little bit of overlapping, that's why this warning is showing. But you can see that in the strip plot there are overlapped. You can't count that how much data points you have in the orange color, they are overlapped. But when you plot it in the swarm plot you can count it easily as they have some space in between, they are not overlapped. So its x-axis represent the gender of the student as a male and the female, y-axis represent the health of the student, this plot represent the gender and the health of the student, and here the blue circles are represented as a and the orange circle is represented as a T. So now we will move ahead and see one more example. This time I want to visualize the swarm plot for the single categorical variable. So I call the swarm plot variable to visualize the G3 data point of the student underscore data set. And here we have only the one single categorical variable, so I call only the x-axis. So I want to add a labels only at the x-axis, so I call the xLabel function, pass the label and set its value as an argument. Then I call the title, and last I call the show function. Now I execute this code also and show you the output. Here you can see that it shows at the x-axis grades of the student, and you can easily count it as these data points are not overlapped, and this plot shows the student grade 3. So with this we have also learned about the swarm plot. Now we will move ahead and learn to create the factor plot. So in Seaborn, to create a factor plot, we use the factor plot method in the older versions. And in the latest version, as I am using the version 0.112 of the Seaborn library, I will use the catplot function, as the factor plot function are not currently working in the newer version. So for this I have to use the catplot function, and I have to set its kind keyword argument to the point. And the syntax of the function is seaborn.catplot, and we pass in parentheses various parameters. The first two parameters are x and y. These are the data points that define the x and y axis location. The next one is hue. It is a grouping variable that will produce a component with different colors. The next one is kind, and it is used to define what kind of a plot you want to draw. As I told you, if you want to draw a plot as a factor plot, you have to set its value to point. And last we call the data, as it defines what data set we are going to use. So I will show you the example related to the factor plots. So here are the examples related to the factor plot. So I call the catplot function, as I want to visualize the address and the travel time data point of the student underscore data set. Additionally, I pass the kind keyword argument and set its value to point, as I want to create the factor plot. Then I call the x label and the y label function, as I want to add labels at the x axis and the y axis, and I pass label as a argument to it. Additionally, I pass keyword argument font weight and color to the functions, as I want to change the font weight and color of the labels to bold and coral respectively. Then I call the title function, as I want to add a title to the plot, and I pass font weight and the font size as a keyword argument and set its value to bold and 10 respectively. Then I call show function of the pyplot module, as I want to display the plot. Now I execute this cell and show you the output. Here is the factor plot. It shows the address as U and R. U means urban, R means rural, and here is the travel point. So it shows the address versus travel point of the student. So now we will move ahead and see one more example. So I again call the catplot function. This time I visualize the data between age and the G2 grade data points of the student underscore data set. Additionally, I pass a hue keyword argument to group the text data point with different colors, and the kind keyword argument and set its value to point, as I want to create the factor plot. Then I call the x label and the y label function to add labels at the x axis and the y axis, title function to add the title, and the show function to display the plot. Now I execute this cell also and show you the graph. So this is the factor plot. Here the x axis represent the age and the y axis represent the student G2 grade. So here you can see that we have two colors of a line. First one is blue and the second one is orange. So the blue color line represents the female and the orange line represents the male, and this plot shows the age versus grade of the student. So basically it represents the points with the lines. So here you can see that we have a points in the circle form, and this lines are represented as a line chart. I will show you one thing. If I replace this catplot function with factor plot and execute this code with the kind parameter, it similarly created. But in the factor plot function, you can also change its kind to any of the other categorical plot. Suppose I want to change it into the bar chart, so I set the kind value to the bar. But note one thing, here I change the method name to the factor plot. Now I execute this code and I will show you one thing. So here you can see that this time it creates the bar chart instead of the factor plot as a line chart. So I again change it to the cat plot and set its kind to the point, as we want to the simplest factor plot. So with this we have learned to create the factor plot also. So in this video we have learned to create a violin plot, stripplot, swarmplot and the factor plots. And in the next video we will learn to create the distribution plots.